Dear participants, good afternoon in the third session of fourth day of this personality development program. So today we have Dr. KULJEET from Nanak Dev University, Amritsar. She is professor in the Department of Computer Science at Guru Nanak Dev University and joined the university service in 2004. She obtained her PhD in computer science from department in the 2011. She is major research project from 2012 to and presently co-supervising as a research supervisor. She has guided 4 PhD students for the successful completion of their PhD thesis and presently working with 7 research students for their PhD. Her research work includes the contribution that is approximately 150 research papers in the form of national and international conference workshops and presentations. She has a lot of invited talks and she was a program co-chair for the prestigious Open Theme 2021 conference that is held in September 2021. So today ma'am will be talking on the topic of text processing using regular expression. So now I request ma'am KULJEET please address the audience and over to you ma'am.
Okay, thank you so much, Dr. Josen. So I hope we have all the infrastructure working all the time, but sometimes there is a problem and we are not able to sort it out. Okay, so I hope the slides are visible because I couldn't see it on the other computer that I'm using side by side. Is it available? Are the slides available that I have shared?
No ma'am, slides are not visible.
Okay. Okay, let me see that.
Yes ma'am, now it is visible.
Okay, okay, thank you so much. So a very good afternoon to all the participants in this course. I think this is the third or fourth day of the course, and the topics that the topic that I am going to cover today, it's not a topic that you might enjoy a lot, but the thing is that this topic is very, very important when we are pursuing teaching or research of natural language processing. So this topic is a bit you can say technical, or you can say it is a bit boring from that point of view. But looking at the significance of this topic, I think it's very important that we go through this in detail. So we have been allotted some time for today, and I hope we will all make the maximum use of this time that we have been allotted. I'm going to start with the presentation, and this topic is text processing using regular expressions. So the first thing I think that we should talk about in the beginning, because we are talking about natural language processing systems, and these systems they came into existence in, you can say, 1960s. We are nowadays talking about chatbots, right? All the commercial websites, they make use of chatbots, but there were systems which were already there, and long time back they were invented. So we will start our discussion with ELIZA. I hope some of you might have heard about this system when we talk about artificial intelligence. So this topic is mostly there. So ELIZA, basically I'm here giving you a conversation between a user and ELIZA. So you can just go through this conversation the user is typing some text on the prompt and ELIZA is responding. So ELIZA is a computer program which was created in 1965. And this program, like, we just enjoy the kind of conversation a user can have with ELIZA. So you can see that the first sentence, it's a kind of dialogue-based system. The user is mentioning, "I'm unhappy," in the first sentence. And ELIZA's response, which is in capital characters, it is that, "Do you think coming here will help you not to be unhappy?" So we can see that one word, unhappy, ELIZA has picked it from the text that user entered. Okay, then user said, "I need some help, but that much seems certain." And then to that, ELIZA responds, "What would it mean to you if you got some help?" And we again see help has been picked up by ELIZA from user's input. Then user mentions, "Perhaps I would learn to get along with my mother." And ELIZA responds, "Tell me more about your family." So like you can see, mother, mention of mother is linked with family. And then user says, "My mother takes care of me." Then ELIZA says, "Who else in your family takes care of you?" User says, "My father." And ELIZA again responds, "Your father." So this kind of conversation, you see, ELIZA is picking some words from the sentences that user is typing. So ELIZA is a program, and its response is basically based on whatever the user is mentioning in the responses that the user is giving to ELIZA. So this thing we have noticed that the text that the user is mentioning, ELIZA is picking some of that text from the conversation. So let us see next. If we continue with this conversation, then we can see further that user says, "You're like my father in some ways." ELIZA says, "What resemblance do you see?" Right? And in the next sentence, user is mentioning aggressive as the word. ELIZA is using that word aggressive in its response. User mentions argue in the next sentence. ELIZA mentions argue in the response. And user mentions afraid as a word in the sentence, and ELIZA responds using that word. So what kind of observation we can make in this is that ELIZA is a computer program which is interpreting the user inputs, and using those inputs as indicators, ELIZA is framing some responses and answering the user. So important thing is that how does the user you can say perceive that kind of communication with ELIZA, and you'll be surprised to know that when this system was invented, when this system was created, and user response was like user feedback was taken, the surprising result was that people who interacted with ELIZA, they believed that this machine or this program, it really understood their problems, right? And even like when they were told that ELIZA is not a human being, or ELIZA doesn't have much of intelligence, it is just a computer program, even then they continue to believe that ELIZA is really capable of understanding their problems. So this ELIZA, this computer program, this was created by a Rogerian therapist, right? So this was again a kind of system which was invented to understand that how a computer program can be used to communicate with a human user, right? And this computer program, it used a pattern-based method, right? And that pattern-based method, that is the concept of regular expressions. So Eliza is looking at the user input, and it is just trying to identify certain patterns in that input, and using those, learning those patterns, it is trying to respond to the user. So we are today we are taking up this topic of regular expressions, and you see this concept is behind all kind of natural language processing. Like it may be being used for creating chatbots or for any other kind of processing, because nowadays we have huge amounts of natural text that is available. How we can get some kind of data out of this natural text, right? It's not possible to manipulate these large data sets without using any kind of automated methods. This pattern-based method, this regular expressions approach, this is a very, you can say, easy way to manipulate large amounts of text, but it is not that easy as it sounds. So we will explore this regular expressions like for the purpose of using it for text processing. These regular expressions, if we just talk about what are regular expressions, these are you can say a kind of patterns that we want to search in data, which is in the form of strings, like sentences, and we are using some standardized syntax conventions. So there is a specific syntax that we have to follow if we want to search for a particular pattern in some text, right? So we will learn how to form these patterns, how to form these search strings using the syntax which is available in with these regular expressions. So basic thing, broadly, what we can understand about a regular expression is that a regular expression, it has just two different types of characters, right? Two different types of characters. So in these two different types of characters, some are the literals, like all the alphabets of the English and all the digits like 0 to 9. These are all characters. These are all literals. And then along with this, there is another category of characters that we call meta characters. So meta characters are basically like your plus, dot, star, asterisk, right, or question mark. So these are some of the symbols that I'm mentioning. Parenthesis is there. So these all special symbols, they are called the meta characters. So we will learn how to create a search string, how to form a pattern that we want to search in text using a combination of literals and the meta characters. So this is like I'm starting with one example. At the, you can see, heart of this slide, you see there is one expression, and this expression is like given some literals are there, and then there are some meta characters. So before this expression, the paragraph that we have, it mentions the literals that are in this string. So what literals we have? We have F here, HT, T, P, S, right, and the colon. So these are all literals. And what are the meta characters in this expression, in this search pattern? The meta characters, they start with these parentheses. Parentheses are there, starting and then ending. Then there is a pipeline character, pipe character we call vertical. Bar is there, then a question mark is there. So these are the meta characters, right? So when we are reading a pattern, search pattern in the form of a regular expression, we first we can start from that what are the literals in this expression and what are the meta characters. So any regular expression is just a combination of meta characters and literals. So if there are any questions from participant side, you are most welcome to interrupt. Okay, then we have, if we go by the definition of this regular expression, basically it is a language. Regular expression, it is a language. It has a vocabulary, like we have seen. What is the vocabulary? Vocabulary is your use of literals, and the meta characters, they form the vocabulary of this language, and then there is some syntax, right? So this language is for specifying text search strings. So I am again repeating, what is the purpose? We have, suppose, a kind of some text in the form of like, for example, Shakespeare's novel is there, and we are doing some text processing on that text, right? So we want to search for that, what is the frequency of this word in Shakespeare's text, right? That kind of thing, suppose we are doing. So how to look for different types of words, right? We can use this regular expression as a language for framing the search strings, that what we want to search from this text, right? And this language, it is nowadays used almost all the computers. Have your Java, Perl, all make use of regular expressions. Even in case of Unix, there are many tools which are for text processing, and they all make use of regular expression as a language. And then there is a formal definition. You can just read it out, that it is an algebraic notation because it makes use of some mathematical symbols and algebraic symbols for characterizing a set of strings, that whether the strings match a particular pattern or don't match a particular pattern, that is determined. And these are particularly useful for searching in text. So at the bottom of this slide, you can see that we have a pattern. You can see that there is a pattern to search for some text in some string in the text. And how we are mentioning this? So suppose the corpus of the text, that means the whole the text document that we have, it has 3 words like car is there, can is there, cat is there, and we want to see that where these words are occurring. We just want to match these 3 words with the text pattern. So how do we mention that text pattern? Because CA is common in these 3 words, right? So we mention CA as such, right? CA, we don't mention any meta character with that. We mention CA directly. After that, we just want to say that this any word which starts with CA, and the third character it has could be T, or it could be R, or it could be N, right? So any of the 3 characters, so T or R or N, this X or Y or Z, we enclose these 3 characters within the square brackets, right? So when we search this pattern will match all occurrences of car, can, cat, right? So in this way, we are framing a search string, and this search string, this is called a regular expression. And then we see what is the output of this regular expression. Okay, and now what are the main uses for regular expressions? Like you can say, what are the applications of regular expression? Regular expressions help us to search, like we have just seen. We frame a pattern, we frame a search string, and then corresponding to that search string, whichever words in the text match it, they are all automatically highlighted, or they are all selected. Then on the similar lines, if we are able to search, then we should be able to replace it also. So if you want to search for a particular pattern and you want to replace it with another pattern, you can use regular expressions for that purpose. Then third thing, like many of you might have seen this kind of application where we want to validate input of a user. So for example, a user is filling a form, and the user is supposed to fill their email ID, and we want to see whether the email ID is correct or not. So it should be that it should have all the components of a correct email ID, username, name of the website, mail website, and then dot, and then com or org, whatever it is. So corresponding to that, in our program, we can create a search pattern, a regular expression, and then whenever the user enters any data, it is compared with the email ID that the user has entered. So like you can see whether it is fulfilling the criteria or it is not. Similarly, you can compare the password that the user has entered. So many times we see that password should be strong. So whatever the criteria of that strong password you want to have, you can mention it in the form of a regular expression. And whenever the user enters a password, you can compare that password with the regular expression. And if it matches, it is okay. Otherwise, you can suggest to the user that your password is not that strong. So similarly, like we want to coordinate actions. Like for example, this I think we have been doing in the past as well, that you are using a command prompt, and on the command prompt you want to process certain files in a folder, and you can just select using any wildcard characters. I think we all have that exposure to using asterisk as a wildcard character to select all the files which match certain names, right? So that kind of thing we can do with these regular expressions. Okay, so this is an example of how a regular expression can be used in Java language. So like in the similar way, regular expressions are supported by many other languages, programming languages as well. So if we are not using a regular expression approach, then you can see the code on the top is there, which is available in standard Java. That means you look for the @ symbol in the email, right? And then you check whether that email ends with org or not, right? So depending upon whatever criteria you are choosing. But if you can do the same thing using a regular expression, that code will be more compact, right? So that you can write, the expression is given at the bottom of this slide, that if you're using a regular expression, how you can do the same thing. Then if you have some experience of searching for text in MS Word, right? MS Word also supports some kind of this pattern matching, but it is not the way the programming languages they support. So this in this example, you can see that if we are looking for AND word, so AND is there like as an independent word, and is there as a part of some other word. So like this kind of matching is possible in case of this word processor that we most frequently use. That is like the application that we have, but it doesn't support the kind of regular expressions that we are going to learn today. So this is just what we were talking about, that on the command line, you can use wildcard characters to match large number of files for some criteria. So like this is again that we have already seen, but it tells us something more about that. That any regular expression, it has two types of characters, like the literals and then some special characters. And these special characters, they are called meta characters. So on this, whatever you see in pink color, I'm just using different types of colors so that it could be more interactive. And like we have this a series of characters, like starting with dot, then caret sign is there, then dollar sign is there, then square brackets are there, plus asterisk, question mark, and a dot again, and then a slash is there, then parentheses are there. So these are all called meta characters, right? So we have two types of characters, literals as well as meta characters. So we will start with something very simple, and this is literal matching alphabets. Like, so this is to begin with. We are not using any kind of meta characters. We are simply using simple text only. So if you want to find out the word cat in a text, so you just mention cat, and it will correspond to all occurrences of cat in the text. And you can see that cat as a word, it is a part of concatenation, delegate, located, modification. So wherever this sequence of 3 characters is there, cat, alphabets 3, so that all will be available. That means that all will be result of applying this cat as a search string to any piece of text. So this is the basic thing. This is a very simple, you can say the simplest mode of writing a regular expression is this one, where we are mentioning just a sequence of 3 alphabets, or any sequence of alphabets. That means you can mention any word, and we call that a literal, any word as a search string. We are not using any meta characters. We are not using any special characters. So this is normally simple. You can just type any word and that word will be searched. So this is, in this case, it is just working like our MS Word. Then similarly, like we saw how to match a word, similarly you can match a sequence of numbers also. So if you have like 123, you just like use this as a search string, and whatever numbers are there in this sequence, 1, 2, 3, they will be all matched. So in this example, like we have 4 different numbers which has this 123 as one of their subparts, so they will all be selected when we are looking for 123. Now the things become a little bit more, you can say, towards using this regular expressions, where we introduce the concept of meta characters. So there are several meta characters, and we will start with the one, that is the pair of square brackets, right? So when we have a pair of square brackets, we can use this pair of square brackets to mention any number of characters that we are looking for, right? But the important thing about this meta character that we are introducing, the first meta character that we are introducing, it is the pair of square brackets. So how do we use this pair of square brackets? So within the pair of square brackets, we can mention any number of characters, right? But when their matching is, you can say the system is looking for the strings which are matching with this expression, they will match with the individual characters within this string, within this square brackets. So it is looking for, it is not looking for ABC together, right? It's very important to understand. It's not looking for ABC together. It is looking for A, it is looking for B, it is looking for C. Any of the 3 characters it is looking for. So wherever it finds A, or wherever it finds B, or wherever it finds C, it will match all those, right? And like here you can see that you can mention the alphabets in sequence, like here A, B, C, or you can use this hyphen also. So if we want to say that 3 characters A, B, C, you can simply write A and then a hyphen and then a C. So you don't have to mention B, because B is within the sequence from A to C. So similarly, if you want to say all the small lower alphabets, you can simply write the square brackets and then A and then hyphen and then Z. So that means we say that all the lower alphabets starting from A to Z. And you can mention all the lower alphabets starting from A to H or A to J, or you can say from C to X, any combination you can consider. Similarly, if you want to mention capital alphabets, right, then in that case you will use capital A, capital Z, that way. If you want to combine both, like small alphabets as well as capital, you can put them together within the same square bracket. Like you mentioned first the sequence of small alphabets, and then you mention the lower alphabets and then the upper alphabets. And you can notice that we are not using any comma to separate them, right? So there is no need to use any comma. We simply write the pair of square brackets and whatever sequences we are interested in, matching like small alphabets or capital alphabets, right? So there is no need to mention all the characters. If some characters are in sequence, you can just mention using this hyphen to indicate that we are interested in all the characters which match from A to Z. Now, in this example, you can see that we are using the search string. Let me just make you more conversant with this interface. That I'm using an online regular expression checker, right? So that regular expression checker, I mention the expression that I want to check in this bar, which is on the top in this regular expression window. And then I want to, whatever text I want to compare it with, I mention on the area below this upper bar, right? So you can see test string here in this window. So test string, this area contains all the text against which I want to compare the regular expression, right? And on the right of this, you see match information. So this match information shows the results that are there. So it shows that there are two matches, like match 1 is for this word, match 2 is for this word. And you can also see that it also shows the result on the top, like in green background. It shows 2 matches, right? And then it shows how much time it took to find out these 2 matches, right? So we're not interested in time as such. But if you look at the regular expression, it starts with 123, right? 123 doesn't have any meta character around it, right? It is just direct, literal 123, right? After 123, we mention the pair of square brackets, and within that pair, we mention the sequence A to Z, right? So it matches this search string, this pattern, with the 2, you can say, text strings out of this text. And this is, it matches it with 123A, right? So 123, it will match if 123 is available in the text directly, literally, right? After 123, what is occurring after 123? You see there are 4 lines in the test string box. The first line is 123.45, right? Dot, now dot doesn't match this the later part of 123. 123, after that we have the pattern A to Z sequence within the square brackets. So this dot doesn't match that pattern because we are looking for any alphabets, lower alphabets, any lower alphabet after 123. So dot is not a lower alphabet, so that sentence will not match, that text part will not match. Similarly, in the next line, we have 123 followed by A, right? So A is a small case character, so this word will be, or this part of the text will be selected. So match, you can say match 1 is 123A on the right, you can see. Similarly, in the next line, you see we have 123 as such, but after 123, there is a capital A. So this doesn't match the search string. So this is not selected. Similarly, in the last line, you have 123 followed by X. So that is selected because X is a lower alphabet. Now, what is happening here? It is comparing 123 directly wherever it finds the match, right? After that, it looks for one more character, right? When we are mentioning this square bracket, means we just want one more character. Any of the characters from A to Z, only one, right? Only one character from A to Z. If it matches with this pattern, that means that text sequence will be selected. So I hope it is clear that we are using the first meta character, how this matching starts. If it is a literal, it will match directly. But after that, if there is a meta character involved, then it will compare, does does the next character fulfill the criteria of the pattern or not? If it fulfills the criteria, then it is selected, otherwise it is not selected. So I should repeat it again, this A to Z pattern, which is after 123, either it will match one character or not, right? So if there is, you can say after A, there is some other word, letter. So for example, if it is B also, so it will not select 123 AB, right? It will select only one character after 123. So I hope it is clear. If there is any doubt, you can just put it in chat also. I have the chat window available. Like, I'm just looking at the chat. Can you just send me some message to indicate that somebody is there and you are getting the things that I'm trying to explain?
Yes, ma'am.
Okay, thank you, Nitika. Thank you so much. So now we are on the next slide. And in this slide, we are doing one small exercise. This is not exactly the exercise that I'll give you. Just wait for some exercise in the coming slides. But this is a kind of just a practice thing that we can discuss. So for example, we are looking for the, 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 and we can have in the text the starting with the capital T, or we can have the in the text starting with small t, right? So we know the has the like T in the beginning. It could be small or it could be capital, but it is followed by two other characters, HE, right? So we know HE part of the is a literal part. HE part is the literal part. But what can be dicey here is that either HE is like following a small t, or HE is following capital T. So we just want to put these two characters, T small and T capital, in within the square brackets. And we know how square bracket works. Square bracket means just match one character. So either small t or capital T. You see all the characters in the square bracket, they have this relationship or relationship. So every character has individual standing. So T small or capital T, and you can see in the result that when you are looking for this search string, it matches both the occurrences of the word the. One, the which is with the capital T, that is match 1, and second the which is with small t, and that is match 2, right? So these two the occurrences, they match with the regular expression, which has which is using a meta character, square bracket. So here in this regular expression, we have he as the literal part, and we have a meta character, square bracket. And first it will look at the meta character, square bracket, then it will look inside that square bracket. So what characters we are mentioning inside the meta character square brackets. And similarly, we can look at the second part of this slide. And in this, we are basically using one word. And most of the times we are not sure of, because our English is partly it is based on American English, partly it is based on British English. So one American English, I am not sure, but I think they use Z in analyzing, and British, they use S in analyzing, right? Somebody can correct me if I'm wrong. So this, we want to search all occurrences, and this is a very big problem writing any technical text. Different. That means sometimes you are writing it with Z, sometimes you are writing it with S, and you just want to see that you want to select all occurrences of analyzing, whether it is using Z or it could be starting with you use that character in the square brackets, so it will match a word starting with small a, it will match a word starting with capital A. Then you see literal part of this. Literal part is which is not changing. NALY is literal part. It is not changing. What is changing next? It could be Z or it could be S. So we put these two, Z and S, in the square brackets. And after that, we have the rest of the word as the literal part ing, because ing is also not changing. Ing will remain ing. NALY will remain NALY. What change we can have is that we can have the first character as a small a or a capital A, or we can have the character Z or character S. So we try to match this text with this pattern, and we find that there are two occurrences. There is match 1 and there is match 2. So we are able to select two words out of the text which match with this pattern. So square, simply we were using this square bracket for including the characters. That means either it should match small a or it should match capital A. But what if you want to exclude any specific characters from the pattern matching? So for example, here you look at this regular expression, which is in the center of this slide in pink color. What it means is that we want to select a word, or we want to match a word which starts with LI, right? So LI part is the literal part. After that, we don't want a word which has V as the next character, right? But at the last, we want the E character. So there is a play of one character after I. We don't want it to be anything else. Want it to be first. We write the special opposite of that character, right? Kind of negation create. Then fourth, we play with this. Like word live, do not pick live because we have excluded V list. We don't want V. We say match any character, but it will not match life or live. It will match it with life, right? So F it finds, and now F is not a negated character. So it will pick, or it will, you can say, match this pattern with the word. Okay, this is breaking. Anybody else getting this break in audio? Hello. Oh yeah, I'm also inquiring. Is it only for Vidya or is it for everyone?
I mean, your voice is breaking a lot.
Okay. So should I then change the connection? I don't know where the problem is.
No, earlier it was okay, but now from the last 2-3 minutes it is breaking.
Okay.
Maybe network issue. You proceed, you may continue.
I keep on see it might get good due course of time. Okay, so this is a next expression you can look at, and at the bottom of this slide. In this, we are comparing, or we are trying to match with all the words which end with ION. Right, so ION is out of any meta character. It is a literal part of this regular expression. Okay, should I switch off the video then? Probably that may help. I have to shift to the other window. Hello.
Hello, yes, ma'am.
Okay, so I have changed a bit, like let us see if it works fine then. So I was explaining this slide where we are having the second pattern on the bottom of the slide, which the pattern is ending with ION, and this pattern is matching with all the words which are having ION in them, the pattern ION in them. But before that pattern ION, we want that there shouldn't be character A or there shouldn't be character T, right? So in this example, we are negating two characters, A as well as T. We are negating two characters. And you can see in the output that it is matching with the word MION, it is matching with the word UION, WION, but it is not matching with the word like, for example, publication or implementation, because these words, they have T before ION, right? So it will skip all the words which have A before ION or which has T before ION. And similarly, you can put a sequence over here. You can put a range of characters that you don't want before ION by using hyphen. So you can say the square brackets and then the caret sign, then A, and then you can mention a hyphen, and then you can mention a T. So that means it will skip all those words in which ION is following any character from A to T. So let us move on to the next. I see the slide changing. Is the slide changing for you? Slide change.
Hello, ma'am. We are looking on slide that is excluding a specific character.
Yes.
Non-matching character list.
Check again slides.
The first point is non-matching character list. And example is live with and the square bracket.
Yeah, I got it. Yes. Oh, yes. Now it is okay. Okay, so the same example, I'm just extending it for another case where we are looking for in or on, right? So in this case, n remains the same. So what brackets, because we just want one of the characters to match, right? So in this case, out of I and O, whatever matches are there, so this pattern will match all occurrences of in as well as occurrences of on. So in this case, like in this way, we can form a meta character and use it. I think we will discuss it further. Okay, so this is a small exercise for you. You have to write a regular chat box. So let us see what you are. I think participants we have in the class at this point of time. I'm getting the number is 81. Yes. So let us have some more responses from your side. There is only one. Let us have some more responses. Then there is another second part of this exercise in which you have to match strings for each of the regular expressions. So I think you can look at the second part of this exercise. You have a part of the pattern. Yes. Yeah, 201. And it is matching with the 7 and then with 8. So Dr. Hassan, are there any other options available for this last pattern? So you have mentioned two options. Two strings can match. Yes, Nitika, very good. So you have mentioned that two strings can match 2017, 2018. Yes, you are right. There is no other option available because we have only two digits within the meta character square brackets. So there are no other options. So thank you for your responses. I'm expecting a better response for the next question. Thanks. So let us move forward. So at least we have already covered one meta character, and now we are going for another. Is it possible to use only character of searching for all occurrences of alphabets? That means uppercase Z, lowercase A to Z, and then from 0 to 9, and then under, right? So you can look at this slide that we have a meta character which can replace this line and underscore. So we have to write this long search string slash to this whole pattern. So slash automatically means that we are looking for all letters of the English as well as all the 10 digits and the occurrence. For correct for meaningful. see now this one slash w. Just look at that it can replace of this X and then 0 to 9 and then underscore, and you notice the sign under this caret sign before this regular expression, the sequence. So we know what this caret sign means. This caret sign means negation. So that means we are looking for the patterns where the text does not match any of the English alphabets and any of the digits and the underscore. So you can look at the result in this case in the regular expression window. You can see we just mentioned slash capital W and it excluded. So what it has with the space character, the first character that you are seeing after the, it is a space character, right? It is matching with the space character. It is matching with the greater than sign. It is matching with the dot, right? It is matching with the comma, and no new character is there. So it is matching with all the meta character select. So we don't have to write 0 to 9. Let's see, next we have next we want to see the space character. So we have a lot of white space in text, right? So that white space is in the form of this space character, due to space character, or it could be due to the tab, the new line, or the carriage return, next line. So all kind of space. If you just want to see how much space, how many space characters are there in different forms, like in the form of tabs or new line, etc. So for that, you can use this white space character, special character. It is /s. So this is another meta character that we have in the regular expression patterns. We just mentioned /s, and all the space matches with this. So you can see when we mention /s, the space character, and then the new line character, that all is selected with this. So this is if you want to see the space in the text. Then we have /s, and now it is capital S. So small s matches with all white space characters, and capital S matches with all non-white space characters. So you can see /s is again a reverse of /capital S. So these are all meta characters. They are a kind of they are in the form of pairs. After this, we have, so that was all for matching the occurrences of single characters, right? Now we are starting with how to match repeated characters. So we know when we repeat characters, we have numbers, or we have words, right? So when different characters, they are repeated, we get as a result some words or some numbers. So let us see that how we get the numbers. What happens like when we have a single digit and then we repeat that digit multiple times, right? We repeat that digit once or more than that, so we get a number. So for example, you can see that there is example of a large number, right? So that number, how it has formed, we like that we mentioned one digit and then we repeated the occurrence of those kind of digits. So you see, like the pattern is that we have digit and then we have the repetition. How many times you want to repeat it? So you see, like we have this meta character. We have this meta character. And then within the meta, like in this first expression that you see in pink color in the middle of the slide, 0 to 9 within square brackets followed by star. How many meta characters are there in this? In this expression, there are two meta characters. One is the pair of the square brackets, and second meta character is the star or the asterisk. So this asterisk will determine that how many times a particular digit is repeated. So this means 0 to 9, any digit, any digit. If we don't write the asterisk, that means any digit just once. But when we write the asterisk, it means any digit repeated any number of times. So similarly, we can have a pattern RS. RS means rupees. So rupees is not in any meta character. We have not, like you can say, put rupees within any meta character or along any meta character. Rupees is standalone in this expression. So when rupees is standalone, rupees is treated as a literal. And after that literal, we are looking for a digit, right? And then we are looking for asterisk. Asterisk means the digit is repeated any number of times. We will see how many number of times. Then in the third expression, we are starting the pattern with the rupees, RS. It is not within any meta character or along any meta character. Rupees is followed by a dot, and then it is followed by a meta character which indicates any digit from 0 to 9. Then with a asterisk, that means repetition of the digits to form a number. And then you see slash and dot. So here we want to mention rupees and then the decimal point and then some, you can say in some number in the form of paisa. So that kind of thing is occurring here, that after dot we have another sequence of numbers, right? Now you see in this regular expression window that we have mentioned the pattern which starts with the RS, rupees, then dot. So rupees dot, RS dot, that is a literal part because there is no meta character associated with this part of the pattern. After that, meta character starts 0 to 9, repeated multiple times, right? So 123 matches this part of the expression pattern. 0 to 9 star, 123 matches because a digit is first 1 is occurring, then 2 is occurring, then 3 is occurring. So these 3 digits are occurring, and after that we encounter a dot. So that means dot is not a integer, dot is not a digit, so that matching will stop here. But after that we have a slash and a dot. So slash is a escape character. So we have this decimal point, right? So decimal point is matched, and then you have 2 occurrences of digits 4 and 5. So 4 and 5 corresponds to the last meta character that we have. So this is the way how numbers are formed. So if we want to look for any kind of mention of, you can say, currency or mention of some price or something of that amount. So we can use this kind of regular expression to match with that occurrence of any amount. If you have any question, you can put it in chat. I will see to that. Okay, so then we have, in the previous slide, we discussed matching with the numbers. What is a number? A number is a repeated sequence of digits. And similarly, now we have repeated characters, but now we are dealing with the alphabets. So what is a word? A word is composed of alphabets. Now we are looking for repeated occurrences of alphabets. So how do we put it in the form of a regular expression? that we talk about one character. How do we represent one character? A square bracket, and within that a range of characters. So in this case, we are just looking for small characters only, right? Small characters only. We are not looking for capital characters. So small characters and then a star. So that means repeated occurrences of small characters. So it will like correspond to all the words which are written in small letters. If we want to have a word start with the capital letter, then you can look at the second regular expression in this slide, which is colored in pink, the bottom of the slide. So it starts with the meta character. Just ignore the initial dot. Ignore the initial dot. It is not part of the expression. The expression starts from meta character, this square brackets. Within the square bracket, we have occurrences of alphabets, capital, uppercase alphabets. So out of this sequence, only one character will be matched with it. For this initial part of the regular expression, only one character, one capital character will be matched with this. After this one capital character, next we may have a sequence of small letters, right? So this will form a word which starts with a capital letter. It will match with a word which starts with a capital letter. Okay, so when we are matching repeated characters, we are starting with this dot as a meta character, dot. So dot means that dot matches with any character. Dot matches with any character, and like it can match with anything. It could match with any digit, or it could match with any special symbol, or it could match with any capital character. Dot can match any character. So here we are looking for this expression L dot dot E. So this L dot dot E means that any word which starts with L, which ends with E, which has two characters in between. What are those characters? They could be any two characters. And you see what it matches with. This pattern matches with live, it matches with life, and it matches with any two special symbols, hash and dollar in between, and L and E on the ends. So what number of characters it will match? That depends upon the number of dots. Each dot will match with one character. Okay, so this dot is a kind of meta character which could be repeated as many number of times as you want, and it will match with all the words which start with a specific character, which end with a specific character, but within those two characters there could be any number of characters or any characters, right? So it is not that it has to start with a single character and end with a single character. I mean, it could be any word, like you can say beautiful, and within the beautiful you can skip two characters, like suppose F and U. So that will correspond to other occurrences of the characters in that space. So after that, you have this asterisk as a meta character. Asterisk as a meta character, asterisk is also known as a Kleene star. Kleene star. So this Kleene star, it basically controls the occurrences, repeated occurrences of the you can say symbol that it is following. And how many occurrences it can repeat? It can either repeat like 0 or more occurrences of the character which it is following. So for example, if we want to look for all the words which end with a day, we want to look for all the words which end with a day, D-A-Y. So what kind of regular expression we will form? We know every word, day word, like Monday, Tuesday, Wednesday, they all start with a capital character, right? So we start a regular expression with a capital character, one occurrence of a capital character, and that capital character could be any character from A to Z. So we put it within a square bracket. That means we just want one character. A to Z, only one character. So any capital character. After that, we say that a capital character will be followed by multiple lower class alphabets. And those lowercase alphabets, they could be repeated any number of times. So we have this star. And then we ended the string with a day. So day, as you see, day is not surrounded by any meta characters. Day is not associated with any meta character. So what it is? What is day? Day is the literal part of the search string. So you know literal part is matched directly. Literal part is matched directly as such, but it will match only with those words which start with the capital character and which has some occurrences of lowercase characters. But star says that it could be zero lowercase character as well. It could be zero or it could be more than that. So it could, this search string can match with a word like which is mday, right? It can match with that also, but it will not match with the, for example, today. It will not match with today, because today we have T is the capital character, fine, but after that you have O, right? So today, so it will match with the you can say zero or more occurrences of a character, right? So after T you have O, and then you have day, right? So it will match with today, it will match with T day also, right? But it will not match with the, if the word is not starting with a capital character. If the word is ending with the day, but it is not starting with the capital character, then this pattern will not match with that word. Then you have next quantifier, which will control how many times a character can repeat. So this is the same, like we have just seen Cleany star. These are a few more examples of Cleany star. So you can look at the bottom regular expression window. This bottom regular expression window shows us that we are looking for occurrences of numbers. So 0 to 9, 0 to 9 star. So what it means is, now you see it is matching with 6. So when it matches with 6 means it is corresponding to the first meta character, 0 to 9. There is no character corresponding to the second meta character. So 6 is alone a single digit. So 6 matches with the first meta character. But 500, it matches with the 5 matches with the first meta character, 0 matches with the second meta character, and the third 0 is there because of the star, because of the asterisk, Cleany star. Similarly, you look at 1000, 1 is there because it matches with the first meta character, 0 is there because it matches with the second meta character, and then you have 0 because of the star, next 0 because of the star. So 0, the star will determine that how many times the meta character or the character that is before it, how many times that is repeated. So in case of 6, there is no repetition. In case of 500, there are 2 repetitions. In case of 1000, there are 3 repetitions. So 6 is there because of the first meta character, 5 is there because of the first meta character, 1 is there because of the first meta character. Next digits are there because of the repetition of occurrences of digit 0 to 9. That means the second meta character. Okay, so after this Cleany star, now we have Cleany plus. So Cleany plus operator is also of the similar nature, but here for Cleany plus, the occurrences are 1 or more. In case of star, there may not be any occurrence of the character before it. But for plus to operate, for plus to work, for this Cleany plus to work, there should be at least 1 occurrence of the character before it, right? So here we have this example. You can look at the regular expression window. And in this, we have the first meta character corresponds to any capital letter. Then second meta character corresponds to any small letter. And then it is followed by a plus, and then it is followed by a day. So day becomes a literal in this case. The word starts with a capital character, so it matches with the Monday, Wednesday, Friday. So what is happening for on part of Monday, for the part of Wednesday, which is after W and before day, and for Friday, which is after F and before day RI. So they are all corresponding to this occurrence of the second meta character. So second meta character, for example, for Friday, just look at for Friday, how does it match with Friday? F corresponds to the first meta character, the capital case. Then R corresponds to the second meta character because it is a small case letter. Then I corresponds to the plus meta character because we are looking for multiple occurrences of the character before plus. So multiple occurrences of small case letters, they are allowed. For Friday, there are only 2 occurrences, but for Wednesday, there are 5 occurrences, right? And for Monday, there are 2 occurrences. So plus will work only if there is at least one occurrence of a character before it. If there is no occurrence of a character before it, this plus will not work, right? So it has to have at least one character before it. Then you can look at this example, and this is a exercise for you. And this exercise says that we have this expression A to Z, and then star operator is there, and then a day is there. And when we are looking at the matches, we have match for Monday, it is okay. It matches Wednesday, that is okay. But there is an occurrence of day in this text, and the expression doesn't match with the day. So what do you think is the reason for this? Why it doesn't match with day? Hello, am I getting any response from you people? Why doesn't it match with the word day in this case? Hello, am I getting any response? Hello, you can open your mic also if you want to respond to this. You can open your mic. Because at least 2 characters are required for so one thing is, if there is a star, there may not be any character. For star, 2 characters are not required. Here we are using a star, right? So for star, there might not be even a single character. So 0 or more, it can repeat. The problem with this syntax is that it is not like it is starting with the capital character. It is starting with the capital character. But when we look at the word day, day doesn't have any capital character before it. So it has to first have a capital character, right? It has to first match with the capital character. After a capital character, there may or may not be any small characters. So this pattern will match with a word, for example, starting with T, capital T, and then followed by DAY day, T day. It will match with the T day also, right? Because star means that there may be any small character, there may not be any small character. If there is no small character, even then it will match with that word. So a word starting with the capital character and then followed by DAY, that will match with this pattern. Okay, so only a few are responding to the questions. I hope Dr. Johnson is also monitoring this. Then you have the solutions for this using this star or using this plus, right? So if we just drop the first meta character, capital character A to Z, it starts matching with this, right? It starts matching with this when we drop the first capital character. So now let us see. We have seen this plus, Kleene plus and Kleene star, right? So here we are having a digit and then followed by a plus meta character. So plus meta character means at least one occurrence of the character before it, and there will be more occurrences of that character as well. So at least one occurrence is required. So 6 is having one occurrence of a digit, so 6 matches. 500 is having 3 occurrences, so it also matches. So at least one occurrence of a digit has to be there, then it will match. And beyond that number, it could be any number. It will match with any number of characters, any number of digits after a single digit. So, but a single digit must be there, right? A single digit must be there for it to match. Then we have the last meta character in this category. This is called the optional meta character, or this is denoted by question mark. So you can look at the regular expression in this case. We have the word item, and this word item is followed by like when you look at the text, item is appearing 2 times. Once it is in the form of items, and once it is in the form of item. So if we want that, we should get both the matches when item is followed by S and when it is not followed by S. So we can form a regular expression item. Item is now, we know item is the literal part. After item, we have the question mark. So question mark will match with 0 or 1 occurrence of a character. So even if there is no character, if there is a question mark, it will match with that word. And if there is at least like 1 character after item, it will match with that also. So you can imagine that question mark is a kind of a binary meta character. Binary meta character means it will identify presence of a character and it will identify absence of a character as well after a word. So we have the word item as the literal, and this literal is followed by a question mark. That means that this pattern will match item as well as it will match items. So if any other character is following item, that will also match with item. So this is another example of the same. Here we have slide is not moving. Okay, I just got to know. Let's see. It is moving for me. I have seen it on another device. It is moving for me. Hello. Have you got the new slide?
Yes, ma'am.
Slide is moving for
slide
me.
number 37.
Okay, okay, thanks. So here we have an example of this meta character question mark or the optional meta character, and you see we have this pattern world. Now world, like it could be word or it could be world. So when we want to select or what it will be matched against, it will be matched against references or occurrences of word, WORD, and it will also match with the occurrences of the word world, WORLD. So what about L? L could be there, it will match. If L is not there, even then it will match, right? So 0 or 1 occurrence of the character that is preceding question mark, 0 or 1 occurrence. So earlier we have seen plus, that was 1 or more occurrences. And before that, we looked at star or asterisk, that was 0 or more occurrences. And this is question mark. This is 0 or 1 occurrence. It will match with the words in the text. So you can see in the output, match 1, it matches with the word, match 2 with the word, and last match number 5 is with a word, world, in which it is having the character L. So we have put question mark after L, that look for the words which have an occurrence of L or not an occurrence of L. Look for all those words. So it has matched corresponding to that. So this is just a summary of what we have done as far as the quantifiers are concerned, because these are called quantifiers. Reason being that they control the number of times a particular character repeats, right? A number of occurrences. So we have any character or optional character like question mark, 1 or more, for that we have plus meta character, 0 or more, for that we have the star meta character. So star and plus, they are both called Kleene meta characters, Kleene plus, Kleene star. Okay. Now next in the category we have this slash character. So next meta character is slash. So we know why do we use slash normally when we are developing programs. We just want to give a particular symbol a special meaning, or we want to drop a special meaning from a symbol, then we use a slash character. So for example, we are having this text, are you serious, right? Are you serious is a question mark. Like here we have this question mark as a character. It is not a meta character over here, because this character is occurring in the text. So we want that this character question mark should be matched. So if we want to match this question mark as a character, not as a meta character, but as a character, so we have to put it after a backslash, right? So when we put it after a backslash, we call it a escape character. So you can see that when we match this backslash question mark, it will give us a result. Match 1, you can see on the right, it has selected the question mark. So in this way, we can escape certain characters which has a special meaning in this regular expressions language. And if we want just to use them as a normal character, but like not as a meta character, but as a normal character, then we have to put them after a backslash. Similarly, like you can look at the bottom of the slide, you have a Kleene star as a special character, as a meta character. You want to use it as a normal asterisk sign, then you have to put it slash star, similarly slash n slash t. Now t has a normal meaning, t is a normal character, but if you want to treat it as a tab, right, tab character, then you have to put it after a slash. So this is, I think, a repetition of that. Now this is a exercise. Again, write a regular expression to match these strings. So I think it may take time. Do you want to try this? Do you want to try? Hello. Hello, if you want to try, I can pause for a minute, or we can keep on discussing. Okay, you want to try. So please go ahead. Please go ahead if you want to try. I'll appreciate. So first we have the digit 1, 2, 24. And you know, how do we mention a digit? We use a slash d to mention a digit, right? And this digit can be repeated any number of times, like we have 2 occurrences in case of 24. So slash d and then a star, right? Then you have to look at what part of this will be a literal. What is not changing? Like file is not changing. File remains as such. Found is also as such, right? So file will remain as such, and then you have to account for occurrence of S in two cases and no occurrence of S in one case. Then you have to mention found, and then it should match with the question mark as well. So if you want to match it with question mark, you know you have to escape the question mark directly. So let me see if we have some output. Okay, I haven't got any output in the chat box. Okay. 1, 9. Yes. 1 to 9, it should be Priyanka, then 0 to 9. Right? But you say like 0 is not there. So you can, yes, it will work. Then even then it will work because we are looking for numbers from 1 to 9 only. But you have to test with the plus. Yes, I got it. One thing which is missing is file. It could be file or it could be files. Right? So you have to write something after file. You have to use a meta character after file to account for occurrence of S or no occurrence of S. Right? So I think that part is missing. Rest is okay. Thank you, Priyanka, for your effort. Yes. No, it should not be files like this. It should be, you have to use the meta character square brackets. And we don't want multiple occurrences of S. So there is no need of star. So after file, you can put meta character and then you can put S. So this is the, okay, so you can use this question mark also. Basically, like there are many ways of doing the things. So I have just shown you the slide with the solution to this exercise. And it says that you can use /D and then plus symbol to indicate the digits. And then you can use file as the literal and use a question mark after S. So it will match with all the words which are not having S in them, like with the file in the first string. And if there is a S in some files, like if we have seen in the second and third lines, so it will match it with that. And then found and then slash and then question mark. So this will be the solution for the previous exercise. So these quantifiers like star, plus, question mark, these are called greedy quantifiers because they try to match with whatever input is available in the text string. Maximum input, these characters, they try to match. So that's why they are called greedy quantifiers. And we have seen we can control some occurrences, the repetition of occurrences by using star and plus and question mark. In addition to these three meta characters, there are some more options available which you can use to control the repetition of occurrences. So I'll just explain these three. If you want that a character should repeat exactly n number of times, so you will mention that n like this within the curly brackets. So we say that we are looking for 3 occurrences of a digit, right? So for example, we are looking for number 500 or 100. Exactly 3 occurrences we want. So we mentioned that we are looking for digits 0 to 9, any digit. How many occurrences of that digit? 3. So we put that number within the curly brackets. We are not using plus or we are not using star, because with that we cannot control the number of occurrences. They'll show us any number of occurrences. We don't want any number of occurrences. We just want, for example, 3 occurrences. So this result will show us 2 matches. One is it matches with 500 because 500 has 3 occurrences of a digit. It will match with 100 because 100 has 3 occurrences of a digit. but it will not match with 6 because 6 has only one occurrence of a digit. So with these quantifiers, you can write better suitable regular expressions. Then next option is you can look for at least 3 occurrences. There could be more than that also. So you can look at the second regular expression window in this slide. It shows 0 to 9. After that, we are showing the quantification. So quantification says there are basically within the bracket, we are mentioning 3 and then comma. So it says that minimum 3 occurrences should be there, but there could be more occurrences than this also. So you see it matches with 500 and it matches with 1000 as well, because 1000 has 4 occurrences, so that is also selected. Then the last option that we are discussing, it is having 2 numbers. So that occurrences should be like it can vary from 1 to 4. So it has to select all occurrences which are having just like one occurrence of a digit or any number from 1 to 4, but not beyond 4. You see, if you have written 10,000 in this text, that 10,000 will not be selected because that increases the number of occurrences of a digit. So it will match with the minimum 1 and maximum 4. So basically we are mentioning a interval in this case. So in this case, you can control how many times the occurrences are there. Okay, so the problem is that whatever we are discussing, most of the things are applicable in programming languages, like we have talked about Java or Python, but they may not work like with the MS Word. So if you try to put this kind of expression in MS Word, it will not, it is because like MS Word is looking for literals only. It is not using all these meta characters. Okay, so then there is another meta character, which is, you can say it is for matching alternatives. It is a vertical pipe character. So this you can use to match different options. So like you have, if it matches with this or it matches with that. For example, we want to select all those lines where any of the day names are there, like either Monday is there or Wednesday is there. So it will pick like it has picked 2 lines, right? It is matching with Monday, the line with Monday in it, and it is also matching with the line with Wednesday in it. Then we have very important meta characters, like if we want to match with something on a particular boundary could be word boundary or line boundary. So you want to match something with the beginning of a line or with the end of a line or with the boundary of a word. So let us first look at these 2 meta characters. One is the caret sign and second is the dollar sign, right? These 2 characters are basically used for looking for matches at a particular position in a line. So 2 positions these characters match with. The caret character matches with the beginning of the line and dollar character matches with the end of a line. So if you want to search for some pattern starting with the beginning of the line, then you can put that pattern after a caret sign. So if you want to see that, like you can look at the left regular expression window. If you want to see that is my occurring in the beginning of a sentence, right? So like what is the like what are the sentences or lines in which are starting with my? So you can put a caret character before my, so it will match with all occurrences where my is occurring in the beginning of the line. So you can see this my is occurring on the beginning of the line. There are 2 matches. Similarly, if you want to look at certain words which are occurring at the end of a line, so for that you can put the word and then you can anchor it with the special character dollar, right? So when this day and dollar, like if day is occurring at the end of a line, that word will be selected. So here you can see that we have Monday, Wednesday, and the same day. So day is occurring at the end of a line and it is selected. So we have in this case 3 matches. So we want to see where a particular word is. So day could be anywhere in a sentence. but we are interested in a day which is occurring at the end of a line. Then you want to look for words which are not at a word boundary. I think I should first show you this one. So if you want to look for words which are at a word boundary, right? Suppose we are looking for day. Day is occurring in Monday. Day is occurring in Wednesday, right? We are not interested in those occurrences of a day. We are interested in day which is occurring standalone, right? Which is not within any other word, right? It is a standalone independent word. So we start this pattern with the /b, small b. So small b means it will select the word, it will match with the word if it is the independent word. If it is occurring as part of another word, then it will not be selected. So you see, in case of this example, day is occurring as a standalone word, right? So that is matched. When day is occurring as part of Monday or as part of Wednesday, it is not selected. So now let us look at the previous slide. Here we are looking for words which are not standalone words. So it is the reverse of small b, meta character, right? So here we have capital B meta character. It will look for the matches for this word which are occurring in other word. So like it is not selecting the day, right? It is selecting Monday, it is selecting Wednesday. It is not selecting the day as a matching word. So I think we are left with a very small part of this whole presentation. Now, lastly, I think most probably this is the last one. We have another important meta character, and that is for grouping. So if we want to group multiple characters as a word, right? And then we want to look for a pattern, then we can use this grouping meta character. And how this grouping meta character is represented? It is represented using these round brackets, parentheses, right? So earlier we have seen how square brackets work as a meta character. Now we see how round brackets work as a meta character, right? So these round brackets, they are treating a sequence of words as a group. For example, we are looking for two words. Like one is a guppy with the G-U-P-P ending with Y. Another is guppies, G-U-P-P ending with I-E-S, right? So we are using this OR character, this alternative pipe character. So this pipe character will be giving us both the options. That means it will match with the words which end with Y, or match with words which end with IES. So, but out of this expression, you see, we have a literal part. GUPP is the literal part of this expression. So this GUPP will be matched. After that, it will look for the match in which GUPP is ending with a Y. Then it will look for a match in which GUPP is ending with a IES. I think we should have an example of this. So this is an example of a sub expression or grouping. You just look at the text first. In the test string window, look at the text first. So this text shows that there are three words. One is order ID, second is ordered, and third is orders. So if we want to match with all the three occurrences of order in different forms, like when it is mentioned as part of order ID, as part of ordered, or as part of orders, so we know that out of these three occurrences, order is the literal, right? So we mentioned literal part order. After that, we put a sub expression, or we group the three options. So we have these three options, we group them together, we put them within the round brackets. Now when we group them, we put them as alternatives. So first group, second group, third group. First group is ID, second group is S, third group is ED. So we say that it should select the words which match with the literal part order as such, but after order part, It could be followed by ID, the first group. It could be followed by S, the second group. It could be followed by ED, the third group. So when we run this pattern against this text, it will match with the three words. So this is the precedence hierarchy of all these meta characters. Like you have the first thing that will be evaluated in a regular expression is the sub expression or the grouping part of the expression that is enclosed in parentheses. After that, you have the quantifiers in the form of star, plus, or question mark, or these quantifiers, like which restricted quantifiers we have used. Then sequences, right? And then anchors, caret sign, dollar sign, and then disjunction, the or, the vertical bar part. So this is now this is the last, I think. This is if you have phone numbers in a text. If you have phone numbers in a text, now you should relax because this is the last slide of the presentation. So if you have phone numbers in the text and you want to match with those phone numbers, now you see what is the difference in these two phone numbers. If you look at the test string part of the window, the first phone number is starting with the area code +91. Second is not starting with any area code, right? It is just the number, phone number. So if you want to write a regular expression to match with these different occurrences of phone number, how you should write the regular expression for that, right? So we have that in case of the first phone number, it starts with plus, right? So we know plus has a special meaning in regular expression language. So we have to escape that special meaning of plus because we want to use plus as a literal. So we have to follow plus, like we have to write a backslash. So we write backslash and then plus. So that means we are escaping plus. Now after this plus, now this plus is optional. We have put a question mark. Why this plus is optional? Because in the first phone number, we have the plus sign, but in the second phone number, we don't have the plus sign. So plus is optional. So that's why we have put a question mark. After this, we have a group. And what this group is, that like in this case, we have a group formed with the digits. So /D indicates a number, a digit. And after that, 2. So that means we just want 2 occurrences of a number. So plus 91. 91, we know there are only 2 numbers in this. If you are talking about some other phone number, which in which case area code could be of 3 digits, then instead of 2, you will put a 3 over there. After that, we have this underscore, right? So this, sorry, hyphen. Now this hyphen is there. And we put this whole group and we put a question mark. So question mark means that this whole may be there or it may not be there, right? So we want to skip it. If like for the second phone number, we know that there is no area code. So for that, we want to skip it. So after the second question mark, if you are able to see the second question mark almost in the middle of the pattern, so you can just ignore anything before that question mark, right? And you just focus on the last second part of this pattern. And you see in this second part, we have 2 subgroups. The first subgroup is enclosed within round parentheses, right? Second subgroup is also enclosed within round parentheses. So what does first subgroup tell us? First subgroup tell us that /D means any digit followed by 5 occurrences. So you can see in both the phone numbers, we have the first group, right? 91556. So it will match with this subgroup. Then you have a hyphen, right? So in a phone number, we have a hyphen after that. And the last subgroup corresponds to any digit with 5 occurrences. So we have the last part of the phone number like 2, 3, 4, 5, 6. So that is the last part of the regular expression that it matches with. So this is, I think, all. So these are the references, and one very like the beauty of this topic is that you have a lot of online material on this. So this rechecks101.com, this is a website where you can practice all your regular expression exercises. Like I have also created all these regular expression windows using this website only. Then there is O'Reilly's Mastering Regular Expressions book that I really like. It's a very good book. And the last thing is you can Google regular expression tutorials, and there are a number of tutorials available on this topic. So I hope I have given you some kind of you can say motivation to study this topic in more detail. If you have any questions, you can ask. That is enough
Good
from
evening.
my side.
Good evening, ma'am. Am I
Yes.
audible?
Yes.
Thank you, ma'am, for such a wonderful detailed session. I have a query in the previous slide, that is slide number 55.
55. Yes.
Ma'am, if we want to fix the number, because if we are talking about the phone number, so first 2 or 3 digits are fixed. Suppose 91 here in the second bracket parenthesis we provided that we are having 5 digit, and we
Yes.
can allow 5 digit. So is it any provision that through which we can fix that the first 2 digit will be 9 or 1 or 7 or 2? Is there any provision? Or how to attempt that? Because I'm a little bit confused in that scenario.
Okay, so we just want to fix that the number is either 9 or like 91 or 75. You just want to fix. I think like if you
Yes,
are
ma'am.
mentioning this slash D and then 2 occurrences, just look at the beginning of this pattern slash D in the first subgroup. Like basically this regular expression, this has 3 subgroups. Like I hope you are able to see 3 pairs of
Yes, ma'am.
occurrences, right? In the first subgroup, we are mentioning slash D and followed by 2 occurrences. So that covers all the digits, right? It can cover your 72, it can cover 91, any 2 digits it can cover. If you want that it should be fixed, like one option is you can use that pair of digits as a literal, right? You can use them as a literal if you know that these 2 digits will be always fixed. So I think this is covering all those options that you are talking about. So I'll go with this kind of option rather than fixing. But if you have that kind of requirement, either you can. I'll give you another option.
Ma'am,
You forget.
my
Yes.
question is that in the previous exercise that you told us to do, in that scenario, what we did in my answer, I in because in the question we don't have the value 0. So is it possible to for that so that for the digit portion we can just include some digits like 0 to 5 or 1 to
Yes,
5?
yes. That is that option is there. So you can. I'll give you any another you can say option for writing this, that you can use 2 square bracket meta characters, right? You can use 2 square bracket meta characters. If you have that your first meta character first digit will be either 9 or 7. So in the first square bracket you write 9 7 9 in any sequence, that doesn't matter. You write 9 7 or 7 9, that doesn't matter. And in the second square bracket you can write the second 2 digits, like if it is 9 followed by 1, you can write 9 in the first square bracket and 1 in the second square bracket. If the second option with you is 72, you can write 7 in the first square bracket and 2 in the second square bracket. So that way you will have these options that your number will start either with 91 or with the 72. That kind of thing you can do. I hope
Thank you, ma'am.
it
Thank you
may
so much.
help you. Okay, thank you. Any other question?
The question to the audience.
Okay, thank you so much, Nitika.
Okay,
Thank you so
ma'am.
much.
I have one doubt also. Will this regular expression works for Indian languages also?
Actually, I'm
Or it will
not
work
getting
only
the
on the English?
audio. not getting the audio very good. Like, let me see if I can get it from the others.
Hello, am I audible?
Voice is very low.
Okay, so I just want to ask whether this regular expression works for English language or it will be working on Punjabi or Hindi as well, or any Indian language.
Yeah, yes, that's a very good question. Basically, regular expressions like we have the regular expression language, it works for English, right? At present, what we have seen or what we are exposed to, because we have worked with the programming languages like Python and Java. They all have these kind of PHP, Perl. They all have this kind of compilers for regular expression language. And it doesn't work even for MS Word, like we have just seen one slide on this. I don't think it works for other Indian languages, because for Indian languages the resources are very low. Because I think Dr. Joseph can tell you better about this than me, because Punjabi University has worked a lot on languages like our Punjabi kind of thing. I don't think there is such kind of a facility available for our Indian languages. I am not at least aware of.
Okay, thank you, ma'am. Thank you for the session on regular expressions. Regular expressions are one of the most powerful features, and if utilized properly, they can do wonders. But your explanation of how to use regular expressions in text processing will definitely help for participants, and we all know that it's powerful, but still we all feel that it's little bit difficult to create the correct expression. So this session will definitely encourage our participants for using the regular expressions in their future work. Thank you once again for joining in
Thank
this
you so
session.
much, Dr. Joseph. And I really wish that I could have this session face to face, because it is really very difficult to work on this kind of thing in this online mode. So I really look forward to if we can have this kind of session in a offline environment. I think participants will enjoy it more, and we also, like as a presenter, I think that will be more useful that way. Thank you so much. Thank you so much.
Thank you, ma'am. Thank you. So we are going to conclude this session, dear participants. We have almost covered all of the FDP, and we have left with only one day. So tomorrow again we will join at 9:30 a.m. in the morning for the first session, and tomorrow there will be only two sessions, and in the evening session we will have a multiple choice question. So we will have a test, small test, and we will share the link, Google link, to all the participants, and be ready for that. Till then, goodbye. Thank you very much.